Hello everybody. I'm Andy from ThinkMo. I'm teaching CCIE course. As of today, I'll share with you technology related to CCNA, CCNP, and CCIE. Our topic today is IPv6. First, we need to know, what is IPv6? You've probably all heard of IPv4. It is the fourth version of the Internet Protocol. IPv6 is the sixth version of Internet Protocol. It's short for the sixth edition. IPv6 for short. It's the Internet Engineering Task Force IETF, designed to replace IPv4. But IPv6 is only now being known. Everybody knows that. IPv6 addresses are more than IPv4 addresses. IPv4 is divided into 4 groups. The size is 32 bits. Each set is 8 bits. IPv6 is at the beginning. When it was designed, claimed to be every grain of sand in the world. They can all be addressed. You can see how large the number of addresses is. The size of an IPv6 address is 128 bits. Among them is the one we mentioned, in colons and hexadecimal form. So each group is 4 hexadecimal numbers. There were 8 groups. So it's going to involve. Why use IPv6? It mainly involves. IPv4 addresses are insufficient. So why aren't there enough IPv4 addresses? Since IPv6 was designed in the 1990s, there hasn't been a complete transition to IPv6 yet. First of all, let's talk about it. Why has IPv6 been designed since the 1990s? There hasn't been a complete transition to IPv6 yet. It involves several factors. First of all, there are no obvious applications for IPv6. That is, in the current network environment, nothing IPv6 can do that IPv4 can't. At least since the 90s. Most of the time. Among other things, IPv4 address in 2011. Millions of addresses have already been assigned. Then why is it still there? There's no massive transition. You all know about IPv4. The IP address can be private or public. For the user, we can use private internet addresses. And it's not just about users. Operators can also use private networks to interface with the user. In the process, it involves the technology of NAT. It's called Network Address Translation. Especially in network address translation, it involves something called NAPT. In a nutshell, I can translate multiple private addresses in order to provide internet services. That means the address got a lot of relief. That's the first aspect. The second aspect is VSLM. It's what we call a subnet. Is a subnet mask of variable length. That's the technology for subnets. This technique can also prevent waste IPv4 addresses. And of course, once you do what's called subnets, also to waste less batch address. Let's say we divide a subnet. That's a waste of at least 2 addresses. If there's a gateway address involved, I'm gonna waste 3 addresses. But it has more advantages than disadvantages. Because it can save more IPv4 addresses. Not so much as a network segment are assigned to some host for use. This is what we call interzone free routing. That's CIDR. We also call it a hypernet. The emergence of hypernets has also eased. IPv4 addresses are insufficient. Let's say a Class C address segment. It is a 192.168.1.0 24-bit mask. If we use CIDR, similar to the technology of the hypernet, I can make it Class B or Class A. The IPv4 address of this also expands its range of addresses. Increased the number of addresses. so we all know. For example, 16 has 6,536 addresses. It doesn't matter if 2 or 3 are missing. So these are the things. From this IPv6 perspective, in effect, it stunts its development. Of course, the most important reason is that there are still no protocols or technologies. IPv6 is not required, including our current one, like moving properties or driverless technology. They haven't reached the mature stage yet. That means there aren't any. Very cutting-edge technology is required to use IPv6. So why do we have to do it now? Starting to transition to IPv6. There are several reasons for this. The first is what we call 5G technology. Now 5G technology is developing rapidly. And then there's actually the Internet of Things. For example, some household appliances, probably all connected to the Internet. All industries need to use IPv4 addresses. And it had been allocated in 2011. Even if we use CIDR, variable length subnet mask, subnet division, or a private network or something like that, it can't be relieved. 5G technology. It's right. Network quality requirements are higher. So you want as little as possible, with or without NAT. Because NAT also adds latency. The end-to-end feature is broken. What do you mean end-to-end? It's just an address on my end. Access your host. We're going to implement it in the middle device. It cannot be translated by NAT. This is called end-to-end. So the data can be sent directly. 5G technology has high requirements for bandwidth, including other technologies like security. IPv6 comes with built-in security. It comes with its own encryption. Then there's the Internet of Things. The Internet of Things is all walks of life. Our bias towards automation. Artificial intelligence also means that every electronic device or network device, they all have to be connected. Perform remote control, like the ones that are popular now. Remote operation of automotive air conditioning. They all need an address. That's obviously not enough for IPv4. So let's talk about that. Comparison between IPv6 and IPv4. What are its advantages? The first is the number of addresses. I don't need to say too much about this. IPv4 is 32 bits. IPv6 is 128 bits long. The second is the data header. IPv4 datagrams are bloated. A lot of fields in it. In IPv6, they've been deleted. IPv4 header length is variable. The value ranges from 20 to 60 bytes. IPv6 has the concept of a basic header. One of its basic mastheads is a fixed size of 40 bytes. There are only 8 fields in IPv6 used for data headers. It has a fixed length. If you want to add additional functionality, configure other protocols. What to do? It can be added in the extension header and in other extension headers. The corresponding protocol support is also integrated. For example, support for IPsec its native encryption. IPv6 address after that. It can be configured automatically. Can't IPv4 be configured automatically? IPv4 is delivered by DHCP. That means, if an address is delivered automatically, someone needs to understand the Internet. Configuring a DHCP server for IPv6. Just plug in the cable and you can automatically generate an address. Then you can use it. This is the advantage of IPv6. And IPv4 that we mentioned. It has many other advantages. The most important one is that IPv6 is fast. If you're interested, you can take a look. Where exactly is it? Especially for its packet field. Some mechanics of the whole design, including traffic class, or in the IPv6 header. There are flow tags that are talked about. It's all designed for its speed. IPv6 design from everything has been streamlined. That's all for today. If there are any other skills you would like to learn, feel free to leave a comment or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.